In this video, we're going to talk about how to read function notation from a graph. Now, you've been given here the graph of f of x and the graph of g of x. We don't know what the equation is. It's going to be something weird because these graphs are kind of wonky. They have weird bends, they have jumps, they have holes. So a couple things to remember when we're looking at a graph is just like inequalities, a solid dot like here or a solid dot like over here on g of x, that means that's where the graph exists. That point is a part of the graph. So is anywhere that the line goes through, that represents points that are just so close together that it makes a line. The open circle means not included. Just like with inequalities, you can get close to that dot, but the graph never actually touches that point, okay? So if I have a choice between a solid dot and an open circle, I want the solid dot. That's where the function actually exists, okay? So the two functions have been labeled. They're different. So questions about f, we'll look at the left. Questions about g, we'll look at the right. And so we're used to talking about the x and y axis, but when we're in function notation, remember that y equals the f of x value. And over here on the g of x function, y is going to be equal to the g of x value. So if I talk about an ordered pair, even though I think of it normally as x and y, that's the same as saying x f of x, because f of x and the y value are the same. Okay, so if I look at example A, it wants to know what is the value of f of 3. Now in the previous video, we talked about in words, what does that mean? And so this is kind of the question we need to ask ourselves. Whoops, I don't know where that purple line came from. F of 3 means when x is equal to 3, what does f of x equal? Okay, so we come to the f graph because that's the one it's asking us about. And we're going to look everywhere that x is equal to 3. So x equals 3 is right here. And every single point on this vertical line has an x value that is equal to 3. So our question is, where does the graph cross that line? And it crosses right here. That is the ordered pair 3, negative 6. So since I know that, that tells me that f of 3, when x is 3, f of x is negative 6 because that is the y value right there. And we know that just by looking over at our y-axis. Okay, let's think about C, g of 2. This one's a little bit trickier. If I look at g of 2, first we need to be looking at the graph on the right, and we go to where x is equal to 2, which is right here, and we think all the way up and down. That's all the places where x is equal to 2. Well, what's tricky about this one is I hit the graph twice, but do I really? The answer is no, I don't. I only hit at this ordered pair right here at the top, which is 2, 3, because that is where the solid dot is. This one is an open circle, so that means the graph doesn't actually cross right there because there is no graph there. So on the G graph, when x is 2, the y is 3. So pause the video and see if you can do B, D, and E. I'll come back in 3 seconds with the answers. All right, so for B, f of negative 3 is equal to 0. When x is negative 3, this is where the graph is. That's the point negative 3, 0. The y value is what we're looking for. For D, g of negative 3, this one's a little bit interesting. Here's negative 3. The graph is down here. There's not a dot, but the line does go through it, so that tells us that that ordered pair, negative 3, negative 4, is on the graph, so the answer is negative 4. And then g of negative 2 is another one where we have some choices. Negative 2 goes through here. We want to choose the solid dot, and that's how we get negative 1. Now, F and G are asking the question in reverse. So F says, where does f of x equal negative 3? Now, where is asking what is the x value when f of x equals negative 3. So now, instead of looking at the x-axis, we're looking along the y-axis. So y is f of x. So I want to know, where does the y value equal negative 3? Here's negative 3 all the way across. And I can see that graph hits that line where y is equal to negative 3 2 times. So we have 2 different answers. This is the ordered pair 0, negative 3. And this is the ordered pair 5, negative 3. This time the answers we were looking for were x values. So the answer is x equals 0 and x equals 5. 2 different answers. G is a little bit weirder. G wants to know, where does g of x equal negative 2? So we come over here to our g of x graph. We go to negative 2, and we look all the way to the left and the right. And what do we notice? We never cross the graph. So where does g of x equal negative 2? The answer is never. We just go through open space at negative 2. H and J are more similar to the first 5 questions. All we have to do is find those values and then do the operation. So for example, on H, f of 1, from looking at the graph, when x is 1, f of x is negative 4, plus f of 5, we have that ordered pair already written on the graph. When x is 5, y is negative 3, and so the answer is negative 7. Go ahead and try that last question on your own, and I'll be back in just a second with the answer. So I end up with 7. F of 9 is positive 3. G of negative 5 is negative 4. So when I subtract, I get positive 7. This is really tough. This is very visual. It's a tough one to wrap your brain around, but this is really, really important. So the practice that we do with this is going to be really helpful to just help you understand this even more deeply. And that is it for today.